3.3 is over multiplying matrices. And multiplying matrices is quite a bit different than adding or subtracting. You would think it's similar, in adding and subtracting, you add the numbers in the same spots. You subtract or whatever. Multiplying is not like that. You don't do that. There's actually two different types of multiplication we're going to talk about. The first one is a lot simpler. It's called scalar multiplication. And a scalar is just a number that you multiply the matrix by. And so, like, if you see down here, it's 3 times matrix G, or 3 times any matrix. To do this, so to do scalar multiplication, all we do is multiply each element by the scalar. Kind of like the distributive property. So if we're doing 3G, that's 3 times matrix G all we're going to do is distribute that 3. So if we take 3 times 5, that's 15. So that goes there. 3 times 2 is 6. 3 times 9 is 27. And 3 times negative 4 is negative 12. Number 2, we're doing negative 2. My scalar is negative 2 times J. So I'm just writing in negative 2 in matrix J. And my answer is going to be just the same size as matrix J. So 2 times negative 7 is 14. 2 times negative 8 is 16. And negative 2 times 0 is 0. Number 3, 7L. So we're multiplying by 7. 7 times negative 1 is negative 7. 7 times 5 is 35. 7 times negative 1 is negative 7. And 7 times negative 10 is negative 70. Number 4, negative 4H. So negative 4 times 3, 1, 6, 10. So we're multiplying all of those numbers by negative 4. So we'd have negative 12, negative 4, negative 24, and negative 40. So that's all scalar multiplication is. And you can type this in your calculator. So what I wrote here, you can type that in, 7. And remember, to get a matrix, it's alpha zoom. And you can type that in. However, it's actually probably faster to do it by hand. When we get to multiplying two matrices by each other, that's where it gets a little bit more complicated. So when you multiply two matrices, the order matters. Unlike regular multiplication, if we're doing 2 times 5, you get 10. If you do 5 times 2, you get 10. You get the same thing. But if I have matrix A and I'm multiplying that by matrix B, that is not the same thing as B times A. Sometimes you can multiply A times B, but you cannot multiply B times A. So it's very important that you pay attention to the order. So here's the trick. To multiply matrices, the number of columns in the first matrix must match the number of rows in the second matrix. And I'll show you a little visual to make that easier to figure out. So let's say that matrix A is a 2 by 3. You need to write the dimensions out. And matrix B is a 3 by 3. To figure out if you can multiply, you have to look at these middle inside numbers. Those inside numbers must match. If they match, then you are able to multiply them. So we would say, yes, we can multiply. If those middle numbers are different, it would be no, and we wouldn't do anything else. Now, not only that, but these outside numbers tell us what our answer is going to be. So when you multiply these two, your answer is going to be a matrix. It's actually going to be a 2 by 3 matrix. So these outside numbers, it does not matter what they are. We could have 27 and 53. We could have 1 and 1. They do not have to match. They just tell us what our answer is going to be. These inside numbers have to match. So let's try a few examples. So let's think about matrix G. G is a 2 by 2. And I'm referring back to these matrices at the top of the page. H is a 2 by 2. Let's look at the middle numbers. Do they match? They do. So yes, we can multiply them. We would get an answer. These outside numbers tell us that that answer we get is going to be a 2 by 2 matrix. Number 6, K. Look at K. It is a 1 by 3 matrix. It has 1 row and 3 columns. M is a 3 by 1. It has 3 rows and 1 column. So could we multiply K times M? Yes, we can. We will get an answer, and that answer is going to be a 1 by 1 matrix. Both of these examples we have, these outside numbers do match, but just remember, they don't have to. It's okay if they do, but they don't have to match. J is a 3 by 1 matrix, and M is also a 3 by 1. So these matrices have the same dimensions. So your instinct would probably say, sure, we can multiply them. But these middle numbers do not match. So no, they cannot be multiplied. So the outside numbers don't even matter because they can't be multiplied to begin with. J we said was a 3 by 1, and K we said was a 1 by 3. Can we multiply? Yes. And our answer that we get is going to be a 3 by 3 matrix. So let's go to some actual examples. And you all are very lucky because I'm not going to require you to know how to do this by hand. It's a pretty complicated process. You would fill up this whole box with math. Okay, it's not easy. You get to use the calculator. So I'm going to remind you. You click alpha, the alpha button, and then the zoom button. And then you have to pick your dimensions. And you just type in the problem. So number 9, you always want to check to see if it's even possible. So number 9, we have a 2 by 3 and a 3 by 2. So it's possible because those middle numbers match. So if we go to alpha, zoom, I'm going to first choose a 2 by 3. So you have to move the little box and click enter to change the number, and then you have to go back down to OK. And I'm just going to type in all of these numbers. And then I'm going to click times and go back to alpha zoom. And this time I'm going to pick a 3 by 2. And type in those. It's very important that you pay attention and do it correctly. If you miss a negative, if you miss anything, it'll throw your answer off. So when I click enter, notice my answer is a 2 by 2 matrix. That's what it should have been. And that's my answer. So we're just going to do one more because this just all you have to do is know how to do in the calculator. So I want you to pause the video and try number 10. All right, number 10, we have a 2 by 2 and another 2 by 2. So we know it's possible. So let's type it in. Change my dimensions to 2 by 2. And you should have gotten -5, -29, -5, -17. If you have any questions, make sure you ask. Have a great day.